we are still working with an interval. So you're still going to have a lower boundary and an upper boundary. You're still working with proportions, which means you're going to have a p hat and a q hat. But this time you're working with two different samples, data set 1 and data set 2. So each sample is going to have its own number of items, its own value for p hat, and its own value for q hat. P sub 1, P sub 2. The proportion of success for sample 1, the proportion of success for sample 2, the proportion of failure for sample 1, the proportion of failure for sample 2. You're going to have all these different numbers for each one. And then you're going to take these values and you're going to, well, you're not going to, but the spreadsheet is going to plug them into this equation along with the z-score, which comes from your confidence level, and it's going to calculate the margin of error. You're then going to take that margin of error, you're going to subtract it from the difference of the p hats, add it to the difference of the p hats, and that is going to give you your interval. So again, you have seen this play before. You know how the story ends. It's going to end in an interval with a lower bound and an upper bound, with you calculating a margin of error. And here is how you calculate that margin of error, by using this equation. And again, this is going to be done by the spreadsheet. Here's an example. In this example, what we have is 1,000 randomly selected males. We surveyed them and found that 231 exercise once per week. We sampled 1,200 females and found that 176 of those exercised once per week. And the question is, estimate the difference in proportion, the difference subtraction, right? The difference between the male and females who exercise once per week at a 95% confidence interval. So if we were to project this to the entire population, we could say we're 95% confident that the difference between the number of males and females that exercise once per week is within this interval. So here is the values for N. Here are the values for P. Here are the values for Q. The number of items, the proportion of success, the proportion of failure for each situation. We take those values and we plug them into the equation that we just talked about. The spreadsheet will do this for you. And we calculate our margin of error. We take that margin of error, we add it to the difference of the p hats. You take the p hat from the first and the p hat from the second, you subtract them, and then you add the margin of error to that. That'll give you your upper bound. You subtract the margin of error, and that will give you your lower bound. So there's a 95% chance that this interval contains the true difference in the proportions of males and females that exercise once per week for the entire population. If you're writing a clickbait news headline for this, you would say the proportion of males who exercise once per week is between 5% and 11% higher than the proportion of females who exercise once per week. A random sample of 214 people who live in the city were selected, and 100 identified as cat people. Like, are you a cat person? Not like a person who is a cat, but like someone who owns a cat, maybe feeds the cat, does that kind of stuff. Okay, so just to clarify what they mean by a cat person, I'm going to put in 100 identified as the cat people out of 214. So out of my 214 city people, right, people who live in the city, urban dwellers, 100 identified out of 214 as cat people. Then we sampled people that live in rural areas out in the country. And we sampled 98 of those people. And of those, 55 identified as cat people. So from our statistics right now, you can see that the proportion of cat people for the city folk are 46%. And the number of people for the country folk that are cat people is 56%. We want to then project this to everyone, right? We want to expand this to the entire population. So we have to put in a confidence interval. So find the 90% confidence interval. Okay, so 0.90 is our confidence interval. And now the spreadsheet calculates the z-score. Thank you very much. It calculates the margin of error. Thank you very much. And it gives you a lower boundary copy paste, and an upper boundary, copy paste. And I'll put parentheses around them. And they want us to round this to 2 decimal places. And so let's submit. Okay, so here we go. A news group is interested in constructing a 95% confidence interval. Okay, let's drop that in right now. 0.95. Boop, we got it. Done. The difference in proportions of New Yorkers and Alaskans who favor a longer NFL season. Of the 530 randomly selected New Yorkers surveyed, 376. So 376 is the number that wanted a longer NFL season out of the 530 that were surveyed. Got it. So that's a proportion, a p-value of about 71%. Now let's go to Alaska. 451 goes here, 572 goes there. So right away, you can sort of tell that more Alaska people favor a longer NFL season just by looking at the values in our sample. But we need an interval. We need a confidence interval. So we punch in our confidence level, we get our z-score, we get our margin of error, and then we add and subtract that to the difference between these two p-values, between the two p-values. So it looks like our interval is going to go from here to here. And we want to round this to 2 decimal places. Before we see if this is correct, let's draw a situation. So we've got negative 13% here. And we've got negative 3% here. And I always like to put a 0 in my graph. I always like to have that 0 in there so I can see. So this right here would be our 95% confidence interval, 95% confidence. We may want to ask, why is this negative? Like, why are these values negative? They're negative because this is the New York minus Alaska. And if Alaska is a bigger number than the New York, your value is going to be negative, right? And think about it. If we have 5 people minus 8 people, that would be negative 3. The difference between these would be negative 3. So what this is telling me is more people from Alaska favor the increased NFL season. Now, if it was the other way around, if there were more people from New York, then you would have a positive value, positive 3, right? And it would be over on the other side. So the sign just indicates which data set has more. Because you're subtracting, you're finding the difference between the two. There are more people in Alaska that favor the NFL season being longer, and we constructed an interval over which 95% confident we are. So now if we take a look at this, so if you went and selected another group of 53 random New Yorkers and 572 random Alaskans, you would expect that about 95% of them would be 95% of the difference in the ratios would land in our interval. And if you did another group of 530 and another group of 530 and another group of 530, you'd expect about 95% to land in our interval. And you would expect about 5% not contained within our interval. And so that's what they're asking in question B, is making sure that you understand what in the world it is you found. And we've talked about this before. The arithmetic is going to be done by the spreadsheet. You don't have to worry about adding or subtracting or doing something incorrect there. What you need to worry about is, do you understand the inputs and where they go, interpreting the inputs, and can you interpret the output? Do you understand when these numbers come out, what they mean? Because if you don't understand what they mean and you just blindly copy and paste them into these answers, that's going to be troublesome. I need a human to interpret the results. I can tell the spreadsheet how to calculate it, but the spreadsheet can't interpret it for me. The spreadsheet can't tell me a story. I need a human to tell me a story. That's what I need you for. You have to be able to take a look at these numbers and tell a story about them. Be able to draw a graph like this and explain it to a 3rd grader and say, okay, 3rd grader, what these numbers mean is if you were to go out and survey these people again and again, probably about 95% of them would fall within here. You're going to survey once and maybe it's here. You're going to survey again, maybe it's here, maybe it's here, maybe it's here, maybe it's here. And then maybe you have one that's over here. And that's okay. You can have things that are outside of your interval. We're talking about probabilities. We're talking about degrees of confidence, 95% confidence. If you want to be more confident, you increase this 95 up to a 98. Now your interval gets a little bit wider. Okay, let's see if we got it right. And there we go. Cool, we got it right.